What happens when water freezes at a molecular level? Have you ever wondered what happens to water when it freezes? Let's take a closer look at the fascinating changes that occur at the molecular level during this process. When water transitions from a liquid to a solid, its molecules undergo a significant transformation. Water is made up of two hydrogen atoms bonded to one oxygen atom, forming a structure known as H2O in its liquid state. These molecules are quite active. They move around freely and rapidly, constantly forming and breaking weak attractions called hydrogen bonds. This constant activity keeps the molecules close but not fixed in place. As the temperature of water drops to its freezing point, which is 0 degrees Celsius or 32 degrees Fahrenheit, the molecules start to lose energy. This loss of energy causes them to move more slowly. When the temperature reaches the freezing point, the molecules begin to arrange themselves into a more stable structure. They form a hexagonal crystalline pattern where each water molecule bonds with neighboring molecules. This hexagonal arrangement creates a unique open lattice structure. This structure has more space between the molecules compared to liquid water. As a result, ice is less dense than liquid water, which is why ice floats. In fact, when water freezes, it expands by about 9%. The freezing process can be broken down into several stages. First, there is a phase called pre-cooling. Here, the water temperature drops close to freezing, but it may still remain as liquid. This is due to a phenomenon called supercooling, where the molecules cluster together but do not yet crystallize. Next comes nucleation. In this stage, small clusters of molecules randomly arrange into the hexagonal ice structure. These clusters need to reach a certain size to become stable. If they do not, they will dissolve back into the liquid state. Once stable clusters form, we move into the crystal growth stage. More water molecules attach to the surface of these clusters, expanding the ice lattice. This entire molecular reorganization involves energy changes. As water transitions into ice, it releases latent heat, which must be removed for the freezing process to continue. Understanding these molecular behaviors is important in thermodynamics. It illustrates how phase changes occur, involving energy exchange and molecular rearrangement. This knowledge helps explain why ice floats, why freezing water can cause pipes to burst, and how freezing shapes natural landscapes through frost weathering. In essence, when water freezes, it transforms from a loosely connected liquid into a fixed hexagonal crystal lattice. This process causes the expansion and solid structure that we recognize as ice.